Welcome back. We now work on Section 10.3 Polar Coordinates Problems from Web Work. Problem 1. The following 3 points are given in polar coordinates. What are the Cartesian coordinates for each point? 3 pi over 2. These are the polar coordinates. R is 3, theta is pi over 2. X is r cosine theta, that is 3 cosine pi over 2. Cosine pi over 2 is simply 0, so x coordinate is 0. Y is r sine theta, that is 3 sine pi over 2. Sine pi over 2 is 1, so 3 times 1 is 3. So x coordinate is 0, y coordinate is 3. Alright. Here, r is 2 root 2 and theta is 3 pi by 4. So x is r cosine theta. So 2 root 2 cosine 3 pi by 4. Cosine 3 pi by 4 is negative root 2 over 2. Okay. So these 2's cancel with a negative. Root 2 times root 2 is a 2. X coordinate is negative 2. Y coordinate is r sine theta. 2 root 2 sine 3 pi by 4. Sine 3 pi by 4 is positive root 2 over 2. So the same situation, instead of a negative, we have positive. Negative 2, 2. Okay. Next, negative 1 pi over 3. R is negative 1. Theta is pi over 3. X coordinate is r cosine theta. Negative 1 cosine pi over 3. Cosine pi over 3 is 1/2. Negative 1 times half, that's negative half. Y coordinate is r sine theta. Negative 1 sine pi over 3. Negative 1 times sine pi over 3 is root 3 over 2. So negative square root 3 over 2. Negative half, negative square root 3 over 2. Next, find the polar coordinates. So you have been given point 1, 1 in Cartesian coordinates. Find the polar coordinates when r is positive. Second part, find polar coordinates when r is negative. Okay, so you are allowed negative r or positive r. So let's understand that. Cartesian coordinates are 1, 1. To find the polar coordinates when r is positive. What is r? It is square root x squared plus y squared. That's the positive root. So positive root 2. Tan theta is y over x. 1 over 1. They are both positive. So you are in the first quadrant. So theta is tan inverse of 1, which is pi over 4. So r is square root 2. Theta is pi over 4. All right. Now, when I take r negative, well, I have to take the negative root. So r is negative root 2 over 2. All right. In this case, if it is on the negative side, my theta has to go around pi degrees or pi radians more. That way, with the negative radius, I'll fall back to pi 1, 1. So you notice pi over 4 is on the first quadrant. So I want an angle which takes me to the third quadrant, so that with a negative r, my point comes back to 1, 1. So that's why we need the pi more. So here r is negative square root 2, and this angle is pi over 4, which was the original one, but this keeps me in the first quadrant. First quadrant angle with a negative radius takes me back, but I don't want to go down back. I want to stay in first quadrant, so I need to add an angle of pi. Okay. Question B. Similar question, you are given Cartesian coordinates. Find polar coordinates when the radial distance is positive or negative. What is r when it's positive? It's simply positive root of x squared plus y squared. So calculating this, you get r equals 4. Tan theta, so keep track of this. This is fourth quadrant. X coordinate is positive, y coordinate is negative. So I'm in the fourth quadrant. So when you take fourth quadrant, theta is tan inverse of y over x. When you simplify, it gives you negative pi over 6, which takes you to the fourth quadrant. But notice, for our polar coordinates, we are not allowed a negative angles. So we simply add 2 pi to get the analogous positive angle, 11 pi over 6. So radial distance is 4, angle is 11 pi over 6. Oops. 11 pi over 6. All right. Now, when we are on the negative side, r is negative root, so negative 4, that's okay. But I want theta. Theta, notice, if r is negative, then I have to look for the opposite side, right? So 2 pi, adding 2 pi brings me to the same location. Adding pi takes me to the opposite location. So 5 pi over 6. So here is negative 4 and here is 5 pi over 6. Let's check. Everything is correct. Okay. Next problem. So this calls for many different graphs. We have 5 polar curves. You want to match, this is the figure you want to match it with. So let's go over this, right? So let's look at this. The curve, I have tried to duplicate it, starts at height little less than 1. So let's call it A. And it goes until height 2, then comes down to A again, then goes up to height 2, comes down to A again. So the highest height you get is at pi over 2 and 3 pi over 2. All right, so maximum distance is obtained at pi over 2 and 3 pi over 2. Minimum distance is arrived at 0 radians, pi radians and 2 pi radians. So which of these curves, the maximum height I can see is at pi over 2 and 3 pi over 2. It starts at a distance from origin of less than 1, then increases until height 2, then starts decreasing until the same distance A, then increases until distance 2, then continues to. So that's graph 1. Okay. All right. We'll continue our video with our problems in the next video.